Welcome to Xamarin University. This session is AZR110, Building an Azure Mobile App Service. Please be sure to download the class materials from the Xamarin University website. This course is a deep dive into the creation of an Azure App mobile service. We're going to focus specifically on the server-side component when developing a mobile Azure application. So first, we will walk through the creation of the Azure mobile app service. We're going to look at both the Node.js approach, which is the default, and the ASP.NET approach, where you can do a little bit more customization. We'll then look at how to add a database to your site. And this is one of the primary features for mobile apps, storing data in the Azure cloud. By the end of this class, you'll have a good feel for how all the pieces fit together and how to integrate an Azure site into your own applications. We're going to start with the server side. You've likely gone through some of this already, but let's walk through it a little bit more completely this time. As you see in this objective, we have a few tasks. First, we're going to talk about the different features that Azure App Services provides to us. And then we're going to go to the Azure Management Portal and create a new mobile app. And we'll create a new mobile app in Visual Studio as well. And then we'll talk about how to set up deployment publishing to get your service up into the cloud. We're going to be working with Azure App Services. Now remember that this is a category of applications you can build in Azure, which include things like web apps to create public websites hosted in IIS. This is typically done with ASP.NET MVC. You could create function apps to allow you to create server-side jobs. These might do periodic tasks like cleaning up a database. We can create mobile apps to create standard REST-based web services to access a database or a web API. We could create an API app to create a public IIS hosted web service. Or we could build a logic app, and this would build a server-side business process workflow, which can be triggered to do data conversions or execute custom logic, or use some built-in Azure features like cognitive services, all done with a graphical designer. We're going to focus on the mobile app service in this class. However, if you didn't want to use the built-in infrastructure on the client side, you could also do everything that we're going to do today with an API app. This creates a REST-based web service which you could then add support for in your Xamarin app using all the techniques we already teach you in our XAM150 web services class. The advantage of the mobile app template is that Azure provides all the connectivity glue to work with the Azure service. Your Xamarin app just uses the supplied client SDK without you dealing with the underlying HTTP protocol. The mobile app template gives you quite a bit out of the box. The server code provides support for 3 basic silos of functionality, which you can see here. The server side exposes data endpoints, which your mobile app can use for accessing data stored in the cloud. For some of these data sources, it also provides built-in offline data synchronization. And that's something that we cover in detail in our ENT410 class, Data Caching and Synchronization. The mobile app service supports built-in OAuth to authenticate your service endpoints using third-party providers, or through Azure itself if you'd like to maintain the database of users yourself. It also supports built-in support for push notifications. You configure the server side with each of the platform notification services and then push your notifications directly from Azure, and it will deliver them to each platform. The Azure Client SDK supports the platforms that you care about: Android, iOS, and Windows in both phone and tablet form. We'll be focusing on Xamarin in this course, but the SDK is also provided for both managed and native versions. Now, as I mentioned earlier, the advantage for the client is that it provides the SDK, which layers on top of the RESTful endpoints that are exposed by your Azure mobile app service. You work with predefined types in the Azure Client SDK, and it creates the HTTP calls, parses the results, and it deals with the errors all on your behalf. We're going to focus on the data stack in this class, and then we're going to leave the other 2 to some future classes that you can take. Let's talk about creating the app server code. Azure supports 2 ways to define the logic for your service backend. The first way is through the Azure Management Portal. If you did the exercises for the AZR110 class, then you've already created a new Azure service with this technique, but we really didn't talk about what happened. When you create a new Azure app this way, the portal creates the server backend using Node.js. Node.js is a very popular JavaScript runtime based on Chrome's JavaScript engine. And Node.js uses an event-driven, non-blocking I/O model that makes it really lightweight and efficient. This is the default server model when you define your service with the Azure Management Portal. It's easy to use, and the Azure Portal lets you do almost everything through the menu options. You can customize the endpoints, and you can even add some limited server-side logic in JavaScript very easily. If you're familiar with Node.js, or you prefer to work in JavaScript, then this is the model for you. And just to refresh your memory, in the Azure 101 class, we use the Azure Management Portal to create our app. And this is super easy to do. Just click the New button and select the type of app that you want to define. Mobile in this case. When we do this, the portal creates a new IIS server instance, and it pre-creates a website using Node.js. To create the app, we have to supply some basic required information. First, we need a name for our app. This is used to create a public URL, so the name has to be globally unique in Azure. It's okay to have numbers or any URL compatible characters. We're only going to need this URL in our app, so this normally won't be a user visible piece of data. Next, we need to select the Azure billing subscription to use. If you have more than one, you can pull down the drop-down and you can select from the known list of accounts. This is going to decide how to pay for any charges that are incurred by the service and its associated resources. We also need to associate this mobile service with a resource group. This provides an easy way to find all the resources that are involved in this service. You can create a new resource group, which is the default, or you can use an existing group if you already created one, or if you want this service to be grouped with some other services. And finally, we need to select the service tier and the region for our new service to be created in. This will default to the last one that you used. You can click on this and you can change the default selection. Once we've filled all these values in, we can optionally pin this to the dashboard, which we do recommend. You're going to be using it a bit. And then click Create to begin the process of creating our service. This will take a few minutes, and once it's complete, you'll be taken to the new mobile app services dashboard. The dashboard for the service will display some basic information about the created service. The most important thing you're going to need is the URL. This is the name that you selected, concatenated with azurewebsites.net. It supports both HTTP and HTTPS. If the app service has a public-facing component, so for example, maybe it's a full website for web-based configuration, you can also map additional URLs to the given URL as DNS aliases. Finally, if you prefer not to use GUIs or web pages, you can generate the Node.js server along with some example files using a command line interface. This is oriented towards Linux or Mac OS, but it runs just fine on the Bash shell on Windows too. And this uses yeoman.io, which is a code generation engine. And this allows you to generate the server backend locally there on your development machine, make any changes you want to it, and then upload it to Azure when you're ready to deploy it. To use the command line approach, you first have to install the Yeoman generator using the Node package manager. The package name is Generator Azure Mobile Apps. This only needs to be done once for each machine. Once that's finished, you can use Yeoman to create a new Azure mobile app. This command places all the files into the current folder, so make sure that you create a folder and you're inside that folder before executing this command. The easiest way then to publish your code is to use FTP. To do that, you must first set up FTP login by supplying deployment credentials. Then you can use the FTP hostname that's listed on your dashboard or in the app properties blade to connect to the server folder. Notice that the deployment username includes a server host. You must add that when you log in. Most operating systems include some form of FTP client support. Windows and Mac can use the Windows Explorer or Finder. FTP provides access to the root of the IIS structure. The second way you can define your backend logic is through an ASP.NET MVC app created with Visual Studio. The ASP.NET approach defines your service using ASP.NET MVC with the model view controller style. Each endpoint has a controller which works with defined models, all defined in a .NET supported language, such as C#. The server backend model is type safe and can use all the extensions and customizations available to .NET. The web project is just a standard Visual Studio solution. This model does require some additional setup work, and most features require a code change instead of just flipping a switch in the portal like you can do with Node.js. It's important to recognize that either backend approach is valid. Ultimately, they will produce exactly the same endpoint. Choosing one model over the other is really just a preference of how you want to manage it, in the portal or in your version control system. If you decide to use a .NET backend, then your starting point isn't going to be the portal, but will instead be Visual Studio. The first step is to make sure that you have the Azure SDK tools installed in Visual Studio. We briefly looked at this in the AZR110 class. You can get these from the Visual Studio installer in some cases, or you can download them from the Azure download site shown here on the screen. There's a version for Visual Studio 2015, Visual Studio 2013, .NET Core, and even the next version of Visual Studio. The SDK is installed using the Web Platform Installer, and once it's present, Visual Studio will prompt you to update the components when updates are shipped. This SDK is primarily intended for the server-side work, and it adds several things to Visual Studio. It was going to add the assemblies for Azure APIs. It will add some project and item templates for Azure features. It will add support for remote debugging Azure services, along with emulators for the storage APIs to do offline testing. And finally, it will add the Server Explorer support for Azure services. Developing the Azure Mobile Service backend with Visual Studio is almost exactly like developing an ASP.NET MVC or Web API solution. In fact, you can use the same tools, languages, runtimes, NuGet packages that you already create your server-side code in, including .NET Core. The primary difference is that Azure will manage the integration, the authentication, and the web endpoints on your behalf. When you leverage the SDK tooling, you won't have to deal with any of that. Instead, you'll be able to focus directly on the logic and the data that's being exposed. Once the SDK is installed, you'll have a new project template available from the ASP.NET Web Application Wizard. You'll create a new web application, and then from the wizard, select Azure Mobile App. On the right side, you'll find a checkbox, which lets you create the app in Azure while you create the service code. That's really useful if you haven't already defined the service in the portal. If you have created the service in the portal, though, you will want to uncheck that option. When you tell Visual Studio to also create the application with Azure, it'll prompt you with a dialog that looks a lot like the portal blade that you filled out for the Node.js version. Most of the same information is collected here. The wizard also adds a web deployment publishing record, also known as MS Deploy or Web Deploy, to the solution. The files are stored in the properties folder, and that generates a unique deployment username and password for you. You can also publish from the command line using the MS Deploy command line tool. The publishing profile is saved as part of your Visual Studio project, but you can also reset it and download a new version from the app portal. This generates a new username and password, and it invalidates any existing profiles. You can then download the publishing profile. This also retrieves the FTP credentials if they're set up. Then, you'll import that new profile into Visual Studio, or use the information in it for command line publishing. One warning about that downloaded file though. The passwords for the publishing process are all stored in clear text. Visual Studio will encrypt them when you import the file so that they aren't in clear text in your source control. Once you have created the app, Visual Studio will be loaded with a new solution that contains a single web server project. This is just a standard ASP.NET MVC app. The app defines two endpoints. There's tables/to-do item, which represents a database table of to-do items, and there's API/values, which represents a simple web service that returns a string. These are implemented through two controllers that are included in the created project. To support the database table, the ASP.NET project also includes a data transfer object, or DTO, named to-do item. We'll look closer at this in the next section. Once you've created your server using either the portal or Visual Studio, it should be up and running once the dashboard is visible. You can verify this by typing or pasting the URL into a browser. A default page is displayed to indicate that this is a mobile app service. Now let's walk through our first individual exercise. Here we're going to be building a survey app, which can collect responses from a mobile app. We're going to start our project by creating our mobile service in Azure. You will need an Azure account, which you should have created or set up in the AZR110 class. There are two versions of this lab exercise. We will walk through them both. One is going to use the portal, and the other uses Visual Studio. Now to start with, go ahead and open the starthere.html from your lab materials. Here, the worksheet will walk through each individual exercise that we'll be going through today. Exercise 1 will walk us through creating our Node.js backend or our ASP.NET backend. We will go through both of these together. Let's start with the Node.js backend. The first thing we need to do here is open the Azure portal. Go ahead and open portal.azure.com, sign in with your credentials, and you should see the dashboard like we have here. We need to create our mobile backend. Easy way to do that is simply click the New button, and then we're going to select Web and Mobile, and we will choose Mobile App. Now we need to fill out the details of our mobile app. You can name this whatever you would like. I'll go ahead and name ours. So I've chosen to name that AZR for Azure 110 demo. Notice the .azurewebsites.net. That's going to be our URL. We need to choose our subscription, and here I have a few to choose from. I'm just going to pick the Visual Studio Enterprise. And next we're going to create a resource group. We need to pick our location. Here I'm going to pick North Central United States. That's the closest to where I am, so that's going to reduce the latency. And I could choose to turn App Insights on or off. Lastly, down at the bottom there's a check mark for Pin to the Dashboard. Let's go ahead and select that and then click Create. You can see the status here, and if we want to check the status, we can click this notification icon, and that's going to show us that the deployment has started, and we're going to wait for that to be complete. Our mobile app is now completed successfully. We can see the details here, the overview. The important thing that we're going to need is the URL. That is what our mobile app is going to connect to. That's where all of our services are going to be located. You can see what that looks like simply by clicking on that link. And for the Node.js template, you're going to get a nice blue screen like you see here that says that the web app has been successfully completed. And now let's walk through that same demo, but this time we're going to be using Visual Studio 2015, and we're going to use ASP.NET MVC to create our service. So we'll start by creating a new solution. We'll do File, New Project, and the Azure mobile app service is going to be in the web section of the wizard. So we'll create our ASP.NET web application. We need to give this a name, so I'll just call this Survey App Service. Over on the right side of the wizard, you can see we have some of those same properties that we had in the Node.js version. So we need to pick our login information, which is already pre-populated. We need to pick what subscription we're going to use. Again, here I'll use my Visual Studio Enterprise subscription. We could set up application insights if we wanted to, so I'll leave that off for now, and we could just turn off application insights, and we'll click OK. That's going to bring up the next part of the wizard, and here we have a few different templates that we can use. The one we want to use here is the Azure mobile app. Notice that there are also Azure API app and Azure mobile service. We want to use the Azure mobile app. Now over on the right side of this wizard, you can see we have a choice to host in the cloud. This is going to create our service on Azure for us. Now, if you have already created the service on Azure using some other means, then uncheck this, but we are going to leave that checked, and we're going to go ahead and create a new service. So this is going to walk us through collecting a lot of those same properties that we had in the Node.js version. Let's give this a name, and we'll call it Survey App Service. We'll pick our subscription again. We need a resource group. I'm going to pick just the AZR110 that I have already created. And again, we will choose to put this in the North Central. Let's go ahead and click Create. Now, once this project has been created, you can see over in the Solution Explorer that it has created just an ASP.NET MVC application. And it has included two different controllers for us, a to-do item controller and a values controller. If we take a look at this to-do item controller, this is going to be a sample of what our mobile app service is actually going to look like. Now, this project has just been created here locally on my machine. I still can't get to this in Azure. In fact, what I need to do now is publish this project into Azure. Because we selected that checkbox in the wizard to say that we're hosting this in the cloud, it already has all the publishing information downloaded. So we can simply just right-click on the project and choose Publish. We're going to use Web Deploy, and here you can see that all the information is already filled out. We are deploying this to my Survey App Service on Azure. And let's go ahead and click Publish. And here in the output, you can see our web app was published successfully to surveyappservice.azurewebsites.net. And just like the Node.js version, we create this placeholder page to show us that our app was created successfully. Deploying your app to App Service is a matter of deploying your code, binaries, content files, and their respective directory structure to the www root folder in Azure. There are several ways to accomplish this. First, as we've seen, you can set up FTP credentials and then upload from your favorite FTP client. This is strictly a manual file upload process. It's up to you to identify the proper files and folders to upload. We've also seen web deploy from Visual Studio. This supports diff-only deployment, database creation, transformations of connection strings, and more. The binaries are built there on your client machine and then pushed to Azure. Another option is to use the deployment engine in Azure Services, codenamed Kudu. Kudu is an open source build and deployment engine built for Azure. You can pull the source project from Git or Mercurial source control or from OneDrive and Dropbox folders. This will then do the complete build and deploy the binaries into the Azure service. And then finally, we have continuous deployment. This is where we configure Azure to watch a supported source control system and automatically pull changes. This currently supports TFS, Visual Studio Online, GitHub, and Bitbucket. We've seen how to set up FTP and web deploy already. For all the other options, you're going to use the Azure portal and establish a deployment source. Each source has a different configuration screen. If you use TFS, Visual Studio Online, GitHub, or Bitbucket, you can have Azure set up continuous deployment. So here's how that works. When you set up deployment publishing to one of these three providers, you create a connection between Azure and a specific branch in your source control. This defaults to the master branch, but you can select any branch in your version control system. Once this relationship is established, the developer makes a change and tests it locally, and perhaps runs the change through a test system. Eventually, the change is committed to the master branch in the source control. The source control engine notifies Azure about the commit, and it does that through a webhook. If it's the master branch, then Azure will do a pull request against the changes. The deployment engine will take the source and do a clean build against it. It will restore NuGet packages and create all the binaries. If it's successful, the deployment engine will take the generated content and binaries and replace your service contents. Your site will be down briefly while all of this happens. The next request will then start up the website and start your service. Now, if that brief downtime is unacceptable for your service, you can use another really cool feature of Azure App Services. These are called deployment slots. Deployment slots are essentially copies of your service running on unique URLs. The number of slots that are available changes based on the service tier that's being charged, so lower tiers don't support any additional slots. Each slot has a unique URL and IP address. That means it's a different website. You can have different versions of your code running in each slot as well. With continuous deployment, you can associate different branches to different slots. So for example, maybe we've made a change, we've tested it locally, and then we pushed it to a beta branch in our version control system, which deploys to our beta site. Then you can swap your slots. This essentially changes what URL points at without bringing either site down. Typically, the workflow would be to deploy new code to a beta site, test it extensively, and then swap it with production once it's ready for prime time. The production slot then becomes the beta slot, and the beta slot becomes the production slot. The best part of this is that the swap occurs with no downtime to your service. Existing requests are completed on the current service, and new requests are routed to the new code. When you use .NET to craft your backend code, you have complete control over the service and its code, and also its bugs. You can run your services locally, which lets you debug and step through them, but sometimes bugs really only surface when you're running in the cloud on the real Azure platform. In these cases, it's possible to remotely attach the debugger to your Azure service and do all of your debugging in Visual Studio. This is done through the Cloud Explorer window, which is added as part of the Azure SDK. You must log into your Azure account in this window, and then locate your service under Web Apps, right-click on that, and select Attach Debugger. One key thing to remember is that by default, Visual Studio publishes the release build. And in order to debug, you must publish a debug build in order to debug it with Visual Studio. So just change your build type as part of the publishing dialog if you're publishing from Visual Studio, and this is in the settings panel when you display the publishing dialog. So now we've been introduced to Azure App Services. We've seen how to create a mobile app both in the portal using Node.js and in Visual Studio using .NET. And we talked a lot about how to get that code up into Azure. Now that we have a site, let's add a database to store and retrieve information from. So here we're going to talk about what the proper type of database is to use for our application. And then we'll see how to create the database, how to create the connection, and of course a database is going to need some tables to store information in. We'll see how to do that, and we'll put some data into the database. Now, most applications are going to use Azure to store and retrieve data in some form. Now, as you saw earlier, Azure has a variety of data services to store a variety of types of data. When deciding the type of storage that you want to use, there are a few questions that you should answer. First, how complex is the data that you need to manage? How is it going to be queried? Does it have specific rules or requirements associated with it? Second, how much data is there? Is it measured in megabytes or gigabytes? And finally, is the data structured or unstructured? A better way to ask this is whether the data is textual in nature or binary in nature. These questions should look somewhat familiar if you've ever stored data for an app. We ask these same questions for desktop and web-based apps too. So let's match these up to the Azure data storage models. The first storage choice we have is the one that we tend to use the most often, SQL. Azure supports SQL Server in the cloud as a platform, or any other database vendor as an infrastructure virtual machine. You're probably already familiar with all the features of this platform. SQL Server stores data in columns and rows as a relational database. It supports complex queries. It works best with textual-based data. And it supports enterprise-level features like transactions and stored procedures. The second model we have is the table storage, or the NoSQL approach. And these are databases like MongoDB or DocumentDB, but stored in the cloud. These tend to be quite fast as long as you're retrieving from a specific key. This does not support direct relationships. All the relationships must be done by the client. The data is stored as JSON text elements, and when you query for a record, you always get the entire blob back. One big advantage of table storage is the price. It is significantly cheaper than the SQL option for large data sets. And then finally, we have blob storage. SQL and table storage are horrible at storing large binary files, things like images, videos, audio, etc. These blobs can be cached regionally, and they can have a unique URL associated with them for retrieval purposes. This allows you to combine this data storage approach with either SQL or table storage and store pointer URLs to the data as part of your structured data. We're going to use a SQL database with our app today. It turns out that the mobile app service has some built-in support to expose tables from a SQL server with little to no custom code. And this makes it trivially easy to utilize this storage model. But keep in mind that if your data doesn't fit in the SQL model, or if you prefer to use another data storage technique, you have other choices. To use a SQL server, we have to add a database to our resources, and then define a connection string in our mobile app service that points to that database. You can also use an existing database if you already have one defined. You can even create a secure tunnel to your data center and use your on-premise SQL server. There are several ways to add a database. You can use the new option, as you see here, and then pick Data and Storage and SQL Database. The ASP.NET deployment model can also create the database for you as part of the service definition or the service creation. Alternatively, you can use the SQL Databases option in the sidebar. This blade has an Add button in the toolbar which presents the exact same SQL database dialog you see here in one step. Notice that you have to enter several pieces of information to create a new database, very similar to our mobile app creation dialog. We need a unique database name, a billing subscription, a resource group, a server host, and a pricing tier. The database is just the first part. Then you need to provide access to that database in your app service. To use the built-in table support, the mobile app service expects a single database connection that's named ms_table connection string, as you can see here. This is true of both the Node.js and the ASP.NET backend. This is the default name that's defined in the web config. You can change this if you change the ASP.NET server code or the Node.js definition file. The connection string identifies the server and the SQL credentials used to access the server. One really great feature is that you can define the data connections as properties of a deployment slot. And that means that you can have your beta site using one database and the production site tied to a different database. Finally, another option for creating a database for your service when you're using an ASP.NET backend is to add it to the initial app creation step in Visual Studio. This is accessed through the Services tab of the Create App Service dialog. Click the plus button next to the SQL database. This will open a dialog to let you select or create a new database, and here you have the same inputs as the Azure portal. Once you enter all the required information and click OK, it will add the database and the connection string as resources for your app service. This database will be defined locally in your project and pushed to Azure the first time you publish. Now, let's go ahead and add a database to our Azure portal. And these steps are going to be the same whether you chose the Node.js or the ASP.NET backend model. We're going to come back to our Azure portal here, and we need to add a new SQL database. And there's a couple of ways that we could do this. We could click the New button, just like we did when we created our mobile app, but SQL databases are so common that down here on the left side, there's actually a SQL Databases tab. We can go ahead and just click that. And now we're going to go add a new database. So we'll click the Add button up here, and we need to give this a name. And again, this has to be a unique name. I'll call it Survey AZR110 Demo. You can call yours whatever you'd like. Again, we're going to choose our subscription, and we're going to pick a resource group, and I'll put this back in the Azure 110 resource group. We're going to create just a blank database here, and notice there are some required settings, and we're going to create a new server for this, or pick an existing server. In our case, I'll create a whole new server, and I'll just call that Azure 110 Demo. We need to make sure we give this an admin login and an admin password. Remember to save this login information somewhere. And we need to then come down and just choose our location. Again, I'm going to put this in the central US because that's where I am. And I want my database to be very, very geographically central to where my mobile app is to increase the speed. So we'll go ahead and create that. And we'll come back, make sure we choose the pricing tier, and you can leave the collation that's the same. We'll click Pin to Dashboard, and let's create that. And now our database has been successfully created, but we still have one more step that we need to do. We need to come back to our mobile app, and we need to add a data connection to our mobile app to connect the mobile app to our database. So over on the left side, let's just search for data, and you're going to see that there is a data connections tab. Click that, and we're going to add a new data connection. We're going to pick our SQL database, and let's go ahead and choose the one that we've already selected here, this Survey Azure 110 Demo, or whatever you named it. And then our connection string, we have to configure that. So here, make sure you add the same username and password that we added on the SQL database. Click OK, and that will set up the data connection to your mobile app. And now you'll have a data connection named ms_table connection string. That is connecting your mobile app to your database. Once we have a table and a connection string defined, then we can start exposing SQL tables from our app service. Depending on our backend server code choice, we have different steps to take, but the actual endpoint and its behavior will be exactly the same. First, if we use ASP.NET to define our service, then we need to write some code to expose the proper table controller and a defined data transfer entity object. If we use the default Node approach, then we can actually configure and expose the table completely through the portal. Let's look at both of these approaches, and we'll start with the .NET style. When you're using ASP.NET MVC approach, we need two pieces of information to expose a table from our service. The first is a data transfer object, or a DTO. This is also sometimes called an entity by some frameworks. This is an object definition that represents the data that is going to be passed from the server to the client and vice versa. Each property defines a column in the database which will be passed over the network connection. Second, we have a table controller object for every exposed table and endpoint. This is a class which derives from the built-in table controller of type T class. This base class implements all the database methods and HTTP requirements. You just supply the shape of the data in the form of a DTO. This might sound like you have a bit of work to do to expose a table, but it turns out that it's not that much code, and the Visual Studio template creates both of these for a to-do implementation, which you can then just replace with your own data objects. The data transfer object is a public .NET class that represents the data going back and forth from the client and the server. Anything you want communicated between the client and the server must be present in some form in this class. This class has a second purpose in your service code as well. It also serves as the database model. Notice that it derives from an entity data base class. This is a class in the Azure SDK, but it ultimately derives from an Entity Framework class. Entity Framework is the latest in data access and ORM technologies from Microsoft. It's essentially the same as SQLite.NET if you've taken our XAM160 data and mobile class. The public properties defined on this object are mapped to columns in the associated database table. The base class provides the database requirements, including 5 mandatory columns which are mapped to public properties. There's the ID, which is the primary key, created at, which is when the record was created, deleted, which is whether the record has been deleted by the client, updated at, the last update timestamp, and the version, which is the current version of this record. We'll look at these 5 columns again when we examine the Node.js approach. They are a required part of the database schema for any table exposed by a table controller. You can add them to an existing table, and we'll see this approach in a bit, or you can let NAD Framework create them when it generates the table as part of the code first generation mechanism. As I mentioned a moment ago, NAD Framework is an object relational mapper, or ORM. Its job is to map a table in your database to a .NET type. The DTO you define will determine the shape and the name of the database table that it represents. Each DTO is mapped to a single table in the database by NAD Framework. By default, the name of the class you define will be used as the name of the associated table. NAD Framework will create this table if it doesn't exist the very first time we access the database through NAD Framework. And public properties in our DTO will be mapped and assigned to columns in the database table by name. If you don't want to use this default mapping scheme, or you're trying to map a DTO to an existing table that doesn't quite match up, you can decorate your DTO with attributes from NAD Framework to customize how it maps your DTO to the table. These only change the column mappings. The DTO wire mappings are not changed by these values. So you can identify the table to map to this class. You can also change the name of the column through a column attribute. You can indicate that some properties have no database representation and should be ignored by NAD Framework. And you can add an index to the column so that it can be searched efficiently in a query. These are the most common attributes that you'll add to your DTOs for mobile services, but there are others that you can look up in the NAD Framework documentation. You can define foreign keys and relationships, you can specify the column data type, you can indicate that a column is required, or you can set a minimum or maximum length for the text. The other duty of this object is as the DTO, which is passed over the network connection. The NAD Framework attributes have no bearing on this mapping. Instead, we're going to use either data annotations or JSON.NET attributes to control this mapping. Now, as an example, here we're setting the name of the field that's passed in the JSON data structure to be to-do instead of text. By default, it uses the column name in JavaScript form, so camel-cased property names. We're showing the JSON.NET approach here, but you could also use WCF data annotations, things like data member, to control the wire definition. Either one is allowed and both are fully supported. The second thing we need is the table controller to provide the HTTP front end to your DTO. If you've done work in ASP.NET MVC, then this is going to be very familiar to you because the process is the same. This is a standard ASP.NET MVC controller type. The easiest way to add one to your project is to use the Add Controller menu option. Just select Azure Mobile Apps Table Controller from the dialog. Then you can set the name of the controller, select the DTO that it's going to manage, and also select the database context to add the DB set to. This will create a new table controller class that's tied to your selected DTO and add the DB accessor code to the mobile DB context class so that you can read and write the DTO from the table. The second thing that we need is the table controller. This is a custom class that derives from table controller of type T. And T is going to be the data transfer object, or the NAD definition. Table controller is a built-in class that provides methods to perform operations against the associated DTO table, and it acts as a web API controller mapped to a route. Using the table controller base class provides two benefits over just using the plain API controller. This conforms to the OData version 3 specification, which allows basic filtering and a standardized REST interface to a database. It also implements the internal logic for offline synchronization. As you can see, there are several methods defined on this class. Let's take a look at some of them. The initialize method is called for each inbound HTTP request, and it has to do two things. First, it's going to create a mobile service context, which will be used to query the data. This is really just an NAD Framework DB context. And second, it needs to create and assign the domain manager object. The NAD domain manager of type T is a class that implements the required iDomain manager interface. The domain managers are primarily intended for mapping the table controller CRUD, create, read, update, and delete, to a backend. Each table controller has its own domain manager. Again, it's going to implement the iDomain manager interface. The iDomain manager maps and implements all the table controller CRUD operations for the backend database. Next, the table controller has a set of HTTP action routes defined. And these are mapped by ASP.NET MVC to the HTTP verbs. The first operation, which is generally present, is the GET query. Since the method name starts with GET, this is going to be mapped to an HTTP GET operation. And this method returns a base class method that does basically a select star query on the database. It's returned as an iQueryable, which is then turned into a JSON collection once ASP.NET builds the returning request. The next method is a post operation, which is used to create a new to-do item in this case. This is an insert into the database. Notice that it does the insert using an asynchronous base class method. Then it creates a new URL, which maps to the current table with the unique generated ID at the end. This is returned to the client to identify the generated DB record by a unique URL. And finally, we have the delete operation. This is a call to the async base class method that deletes the record by ID. And the code that you see here is a fully functioning service, minus the update action. The primary goal is to map the HTTP operations to specific database operations for the given entity or DTO mapping. But you can add your own logic into these methods as well. That's the benefit of the ASP.NET MVC approach. It's really easy to customize the logic for both the service and the database being exposed. By default, you must use a prefix on each method that's going to respond to an HTTP verb. When a network request hits the controller endpoint, the proper method is going to be identified using reflection by matching to this prefix. If you'd like to change the names of the methods or be more explicit about how the verbs are mapped to the methods, you can use a set of attributes that you apply to the methods. Now, delete is an interesting operation when you're dealing with cloud-based databases. It's destructive, which means it removes records from the shared data source, which of course can then affect other clients that are trying to work with this data. And as such, it needs to be treated specially to ensure that it is propagated down to each client. And there's two ways to deal with this, and Azure supports both approaches. First, you could just delete the record and then report errors to any clients who think the record is still there. Or second, you could use a soft delete model, where records are never actually deleted, but instead they have this notation to indicate that they're no longer present. When soft delete is turned on, delete operations done through NAD Framework will actually set a deleted flag on the row to indicate whether the specified row is deleted or available. The queries will automatically include a where clause to filter out the deleted requests. This is added automatically by the table controller. Now, regardless of whether soft delete is turned on, every exposed table always has a deleted flag. It's just simply not used if soft delete is disabled. And soft delete is a common solution to synchronizing different clients against a shared database. However, it's not always required. Keep in mind that this is a server-side decision. The client cannot opt in or opt out of soft delete. It's either on or off based on the server table configuration. Whether you decide to use it or not depends on a couple of factors. First, if you plan to support offline data access and synchronization, which is a built-in feature of the Azure client, then you definitely want to have this feature turned on. It reduces the number of sync errors that you're going to encounter. Second, if you need to audit deletes or support the ability to restore deleted records, then this feature is going to be perfect for your business needs. However, if none of these apply to you, then soft delete might just be overhead that you don't need. It makes the database larger because records are never deleted. The ID column cannot be reused, and it has to be a string type, which is the default anyway. And you are probably going to need a server-side function to periodically clear those deleted records. To activate the soft delete support, you must pass a flag to your entity domain manager of type T class, which is part of your initialize method in your table controller. You must pass a true flag as part of the constructor. And this has to be done on each table controller that needs to support soft delete. Now, we've been focusing mostly on exposing data tables from our service, but you can also expose basic APIs by deriving from the Web API base class API controller. This works the same way as the table controller, but it doesn't supply any database connection. You can name the methods, get, post, put, or you could use attributes as you see here. The one thing you should be sure to do is add the mobile app controller attribute. This attribute registers the route, sets up the JSON serializer for all the methods, and turns on the client version checking. Any controller that does not have the mobile app controller attribute applied can still be accessed by clients, but it may not be correctly consumed by the clients using the mobile app client SDK methods. So you have to do it through the raw HTTP client or some other REST-based client code. The table controller of type T derived classes don't need to have this attribute because it's applied on the base table controller class. Let's switch gears and look at the Node.js approach to tables. In some ways it's identical, and in other ways it's actually quite different, even though the end result is the same. First, it uses SQL Server just like our ASP.NET approach. Also, like the ASP.NET approach, the Node.js backend exposes an OData endpoint to query and manipulate the data. However, unlike ASP.NET, we can configure the database table completely through the Azure portal. And they call this Easy Tables because it's easy, and there's no code required to set it up or get it running. And finally, even though code is not required, you can add code in JavaScript to do some basic server-side logic for each of the HTTP requests and database operations. And this is similar to the table controller in ASP.NET, and it's done through a set of JavaScript functions that you can add to the Node.js server files. We cover this topic in a later class when we talk about authentication support. Easy tables are quite easy to set up. There's an item in the mobile section of your app properties which walks you through the setup process. When you select this option the first time, the portal will warn you that you need to configure easy tables. You can click the header bar to start this process. If you are using an ASP.NET backend, the portal will display unsupported service when you select this item. You have to do your setup in code for that approach. This setup process has two steps which the portal will walk you through. The first is to set up a SQL database and a connection string. We covered this earlier and the steps are identical here. The second step is unique to the Node.js backend. You must initialize the server to support easy tables. Effectively, this sets up folders on the server like /tables and /API, as well as some of the basic Node.js configuration. Once you've set up the database and initialized easy tables, you can start adding tables to expose through your service. This can be done in two ways. It can be done through the Azure portal or the web server configuration files. The portal is by far the easiest way to create new easy tables. This adds the table definition and creates the SQL Server table using your associated SQL database. You must apply a unique table name, which is created on your SQL Server instance. This also becomes the endpoint name that you're going to use to interact with this table. Then, you must define the network permissions to access the table. You can define the permission required for each operation type. The default is anonymous, which means there's no security required. We will cover adding security to our tables in a future authentication class. Just like the ASP.NET version, when Easy Tables creates the SQL Server table, it has 5 mandatory columns added to the schema. The ID field is a string. It could be anything, but it has to be unique as the ID, and it's going to be the primary key. If you don't specify it, Azure Mobile Apps will assign the string representation of a GUID to this field. The created at field is a date-time offset field in SQL data format terms that represents the date and the time that the record was created. The updated at field is also a date-time offset field that represents the date and time of the last update. The version field is a base 64 encoded string that represents a unique version. The deleted field is a Boolean. It represents that the record has been deleted, and that is used to support cross-device or soft deletion cases. As mentioned earlier, you can add these columns to an existing table as well, or use this definition to create your own table directly instead of through the portal. Need to fill in the fields with a unique value and add a trigger on the updated at field to set it when it's changed. If you take a look at this blog post, it has all the details on that approach. Once you've defined your easy table, you likely need to add some unique columns to it to store your app-specific data. This is done by selecting your table in the Easy Tables view and then selecting the Manage Schema toolbar option at the top. This opens an editing blade for the table, and that lets you add and remove columns from the table definition. Any operations that are done here will change the schema of the SQL Server database table. The main thing you likely want to do is to add new columns to your schema. When you click the Add Column button, it will prompt you for the new column information. You must add a unique name for the column. This is the column name and the field name in your DTO, so make sure you use a compatible name here, like spaces are a bad idea, for example. You must select the column type, and there's a limited selection here: string, number, date, and Boolean, which map to the JSON data types. The column types are turned into equivalent SQL Server data types. So string is going to go to the nvarchar max, number will go to a float 53, date is going to a date time offset, and Boolean goes to a bit. Make sure you name the column and choose the type carefully. The portal does not allow you to change the column definition once you click that OK button. And it should technically be possible to connect to the underlying SQL database and alter the column, but you can't alter the name or the type of the column through the Azure portal. Once a column has been added, it shows up in the table list on the portal. There's a context menu at the end of the definition which lets you do additional operations on the column. You can delete the column and all its data. You could add an index to the column, and adding an index speeds up searching on this column by creating a database index. You don't need an index to search against the column, but it could help. And you can delete an existing index. Once we've got a table set up, we can interact with it using HTTP-based operations. Our clients are going to connect to a known endpoint on the service. Tables are always exposed from /tables/ whatever the table name is. This is a requirement of the mobile client infrastructure. If you change the routing, then the client is going to need to write the access code instead of just relying on the SDK. It also breaks all of the built-in features like offline synchronization. So don't change the routing. When our client hits the endpoint with an HTTP GET request, the service will perform an async query against the configured database and the specified table. The table has to be configured with either table controller or easy tables on the server side, or you're going to get a 404 returned. The database will respond with a set of rows or a count of the affected rows. The server will then take that response and then package it up as a JSON packet and send it back to the client. To test your tables, you can use any REST client test app. Just use the site URL and then add /tables/ whatever your table name is. And that's going to hit the proper endpoint. Here on the screen you can see a list of some common favorites, but there's plenty of other testing options out there as well. For a GET request, you can simply make the request to the endpoint. But for a post, a patch, or a delete, you're going to need to send an HTTP body along with the request in order to specify which resource that you want to act on. And you're going to set the content type to be application/JSON. And now let's add a new table into our database to support our mobile app. Again, we're going to handle this with both the Node.js way through the Azure portal and through the ASP.NET app using code. We'll start with the Node.js approach. Let's open the Azure portal and then navigate to your mobile app blade. In the search box on the left, search for Easy Tables and click on the result. You'll notice the blue bar that says Need to configure Easy Tables/Easy APIs if Easy Tables has not been initialized already for this mobile app. Click that blue bar. You now have two choices. The first is to connect a database. That is already done for us because we've already set up our data connection. The second choice is to initialize the app service to use Easy Tables. Note that this will overwrite any API site contents. Click the checkbox and then click Initialize App. And once Easy Tables are initialized, now we can go ahead and start adding tables. We can either add a new table or we can import from a CSV. In this case, let's just click Add. And we're going to give this a table name. So we'll call this Responses. And we have some permissions. We'll cover those in another class, but we'll just click OK now. And that table has been created. If we click on it, we can see the definition and the schema. And there we have some columns already created for us. We have the ID, the created at, the updated at, the version, and the deleted. But for our responses, we need some extra columns in there that are relevant to our response DTO. So let's go ahead and click Manage Schema. And we're going to add some columns here. Let's add a question ID, and that's going to be of type string. We will add the name of the response, also of type string. And let's add the answer. And the answer is going to be a number. So we'll have to choose from one of these data types. And we're going to choose number. Now we have our Easy Table set up. And at this point, we actually have a mobile API that is going to respond to our requests. If we go back to our mobile app, so we're going to get this URL here, and we'll copy that. I'm going to use Postman for this. I'll come back and I'll paste that in, and then we're going to go to /tables/responses. Now you do have to click this headers tab, and we need to make sure that we add in the header Zumo API version, Zumo-API-version, and with a value of 2.0.0. Let's go ahead and send this request. And now we get back just an empty array, as you can see there by the square brackets. And that's because we don't have any data in our table yet. Okay, so now we're going to go over to our ASP.NET MVC application, and we're going to configure our database and our database tables in that way. The first thing we want to do is we want to add our response DTO. DTO is our data transfer object. And we're going to do that here in the data objects folder. Let's add a new class, and we'll name that survey response. Each one of our DTOs is going to need to derive from the entity data class, which is included in the Microsoft.Azure.mobile.server namespace. So let's go ahead and add that namespace, and we will derive our object from entity data. And now that entity data base class is going to include all of the required columns for us, including the created at, the updated at, the version, etc. So our survey response class is simply going to need our custom fields. And now that we have our DTO, we need to customize that a little bit so that it can map to our database. The first thing we need to do is add a table attribute, and that table attribute is going to be included in the namespace system.componentmodel.dataannotations.schema, and we'll call our table responses. And we also need to configure the wire transfer for the JSON object, and that is going to be in the newtonsoft.json namespace, so we'll add that using statement. And we're going to add JSON property attributes. We'll do that for the question ID and the answer. Our next step is then to create a controller, and the controller is what is going to respond to our request. So over in the controllers folder, right click and choose Add Controller. And here we're going to choose the Azure Mobile Apps Table Controller from the wizard. Let's pick our model class. In this case, it's going to be our survey response that we just created. Our data context class will be our mobile service context that was created when we created our solution. And we'll give this a controller name. Let's just call it responses controller and click add. And as you see, it's filled out all of our methods for us in order to do get, get all, a patch, a post, and a delete. But sometimes we want to change the name of those methods. Let's go ahead and change the patch, for example. Right now, the patch is just called patch survey response. And by convention, ASP.NET MVC will wire up the patch HTTP verb to find this method. But once we rename it, let's go ahead and name it to update survey response. Then we're going to need to add the HTTP patch attribute, and that's what's going to allow MVC to know that this is the patch method. Let's do the same thing for the post. So instead of doing a post, we will do an insert. So let's rename that to insert survey response and add the HTTP post attribute. That's all it takes, and now we can publish this site up to Azure. We can test the mobile API using Postman again and verify that the ASP.NET MVC app is returning the same empty array that we got with the Node.js app. Now, if you explore the Node.js server structure, you're going to find that the portal defines your easy tables in a pre-configured folder named tables. So here on the screen, you can see we're at the site/www root folder using an FTP client. Now, if you have a bunch of tables that you want to create, it can be really tedious to do each one in the portal. So another option is to define them all by adding the files into the server folders. The next time an HTTP request hits the server, Node will notice that the changed files exist and create or edit your table definitions. Now, this adds a little bit of processing time to the request, so the first request will be a little bit slower than normal. The tables folder contains the files which define your easy table endpoints in JavaScript and JSON. If you've defined a table through the portal, you're going to find a pair of files for each defined table here. You can also create tables by creating the appropriate files in the tables folder of the Node.js configuration. The Node.js backend is going to create the new SQL table for any .js file that you add to the tables folder, assuming the appropriate supporting files are present. So for example, if you create a file named event.js, you're going to get a SQL table named event. If you create a file named contact.js, you'll get a SQL table called contact. If you've already defined an easy table, you have an even easier way to edit the scripts. Just open the specific easy table blade, which shows you all the rows in the table, and then click the Edit Script toolbar button. This is going to open a new Visual Studio Online editor pop-up. The entire site contents are going to be displayed and editable with the Visual Studio Online editor. You can even add or download or upload files here too. No matter how you edit the files, the two files used to describe a single easy table are a JSON description file and a JavaScript table controller file. The purpose of the file is to store the extra metadata about the table that we defined in the portal. Permissions primarily, as you can see here. This information is not stored in the SQL Server database, and it's inserted here instead. The second file is actually the more important one. This is the table script, which is actually loaded by Azure. Sometimes this is called the table controller. It's essentially the endpoint logic for the database requests over the wire. This script is a customization point. The created table variable has various properties and actions that can be configured to manage the server-side handling of the table. You can add pre- and post logic for each operation on the database. You can override access levels specified in the JSON file to enforce requirements and ensure that the portal can't override them. For example, here we're ensuring that you cannot update records. All records must be new in this case. If you're creating a new easy table, you can also add your custom columns into the table controller script. All the required columns are added by Azure automatically. You only define the custom schema. We set the columns property to a JSON object. Make sure to stick with the allowed data types: string, number, boolean, and date. Then turn off dynamic schema so that this becomes the static definition of the table. The SQL Server backing store table will be created the first time this is accessed. If the column definition is changed after the table exists, it will update the underlying database on the next service request. New columns are added automatically. Removed columns are left along and still returned in the dataset. Just like the portal, you can't change the column type after creation with this mechanism. The Node.js model turns this feature on by default. There used to be a checkbox in the portal for soft delete, but that's been removed as of right now. If you decide that you don't want soft deletes, You can turn it off by editing the JSON table definition file. The easiest way to do this is to click the Edit Script button in the toolbar for your Easy Table, and this will open up the server in Visual Studio Online. You can then edit the JSON file and change the soft delete flag to false. And up to this point, we've been assuming that our data is initially empty, and it's going to be populated by the client. But what if we wanted to initially seed our database with some data? The ASP.NET backend has a method to do this as part of the code-first database creation, appropriately called seed database. But this option is not available for the Node.js side. However, there are two solutions that we can take. The first is the portal, and the portal includes an add from CSV option, which allows you to both define an easy table schema as well as fill it with data from a supplied comma-separated file. This approach only works if you use a Node.js server backend. The second method is to create a seed initializer method, and this approach is specific to the ASP.NET server backend. And finally, remember, we're storing our data in a SQL server no matter which backend we're using. So an approach that works with either model is to connect to the SQL server and populate it directly with a SQL Management Studio tool or some other import process. And this approach is particularly useful if you have a lot of data to put into your database. The Add from CSV option is present in the toolbar for an Easy Table API. Just select that in your app's properties, and you're going to find that button. The process is really simple. You supply a file with a comma-separated values from your local machine. It gets uploaded, and the blade lets you select the column data types, and then you upload the data, which creates the database table and fills it with your data. The data file is just a standard comma-separated value file. The first row should have the column names, in case you want them to be added. The other line should have the data for each column, as you see here. The only tricky thing here is that currently the file must have a terminating CRLF on the last line, which makes it look like there's an empty line in the file. Without this, the last line of the file is not going to be imported into your database. It's possible that this is a bug in the current implementation. This feature is still currently labeled as preview, but just keep that in mind as you import your data. When you're using the ASP.NET backend, you can take advantage of Entity Framework's mechanisms to seed data. The template creates this code for you, but it has to be modified to add the specific data that you're going to need. This is just standard Entity Framework code. If you've used Entity Framework in the past, you can use the same techniques here. The code is placed in the app start folder of your project in a source file called startup.mobile. That file contains a class which is used to initialize each of your tables. In particular, the seed method can be used to populate tables with data by pre-filling the database context for the table. The last option is to connect to the SQL database and populate it directly with data. The main thing that you need here is the connection string. This is found on the dashboard for the database that you've defined. We've highlighted it here. With the connection string in hand, you're almost ready to connect, but there is one more step. By default, SQL databases in Azure are private. You have to add rules to the firewall to access it through an external API. This is done through the More menu on the SQL Server dashboard for the database. Select Set Server Firewall option to open the configuration blade. You can then add each IP address or a range that you'd like to allow through the firewall. You must enter the changes one at a time though, and click Save. Multiple changes will probably result in an error. This can take maybe up to 5 minutes to reconfigure the firewall, although in my experience it's pretty fast. Now you can open the SQL Server Management Studio from your allowed IP address and connect to the server using the connection string information. This is primarily the server URL, the username, and the password. And once there, you can add columns, you can alter the metadata, and you can insert or manipulate the rows. For our last exercise, we are going to populate our database with some initial data. And this is a very common requirement for mobile apps, to be able to see the database before the users start using it. We'll begin with the Node.js and Azure Portal app. Open the app in the portal. Remember that the Node.js backend is using Easy Tables, so search for Easy Tables on the left side of the portal and select it. We have already created our responses table, but now we're going to create a table to hold our questions for the survey app. Click the Add from CSV button and then select a file. We have included a sample questions.csv file in the Part 04 resources folder. Select that and notice that we could change the name of the table or the type definitions of the columns. Click Start Upload to create the table. If we go back to the Easy Tables blade, we'll see that we have a new table named Questions. Clicking on that will show us the schema, including the required columns and our custom columns as well. When we return to Postman, we can change the URL from the responses table to the questions table and make another request. Now we get back our data. Now, let's move over to our ASP.NET MVC app. Instead of uploading a CSV, we're going to include our seed data in our code and import it with Entity Framework. First though, we need to create our DTO and controller to support the questions API. To create the DTO, right-click on the data object folder and choose Add Class. Let's name this Survey Question. We'll add our required namespaces again, and make sure to derive the survey question from the entity data base class. We'll go ahead and name this table Questions. Next, let's add our custom fields. We'll add the text and the answer properties. Next, we need to add another Azure Mobile Apps table controller. Select the survey question as the model and the mobile survey context for the database context. We'll change the name of the controller to Questions Controller. In order to add our seed data, we need to create some objects in code. You can find this Data Factory class in your worksheet. Let's add a new class to the App Start folder and add our questions data there. Next, in the startup.mobileapp file, look for the Mobile Service Initializer class. We want to change the base class from the default of create database if not exists to drop create database if model changes. Each time we change our model, we'll be sure that our schema changes as well. Be careful here though. This will drop your entire database, including any user-generated data. In the seed method, we can remove the sample to-do code and we'll populate the survey questions table with our Data Factory data. Now we can publish the app to Azure. Finally, we can test the API with Postman and verify that we're getting our questions returned to us. Once you start receiving requests, you can see activity through your app blade. There are a few places to watch. First is the live HTTP traffic item. This is currently located under support and then troubleshooting, as you can see here. This will show HTTP traffic to the IIS instance and reported server errors over time. If you find that your service is returning errors, you can dig a little deeper by turning on diagnostic logging. This is done through the diagnostic logs item. There are several things that you can activate which correspond to the IIS logging most web admins are familiar with. You can turn on application logging, web server logging, detail error messages, and failed request tracking, and then click Save. Then use the log stream item to monitor the log on disk. Azure will read this live as it changes and show you what's happening on the server, including exception information if you turn on the diagnostic tracing. Finally, while it's beyond the scope of this class, you can turn on Insights reporting on your site to track activity from specific app instances or users. This will collect analytics on your behalf, which you can then go through with the Azure console. Insights is Microsoft's offering, and it works very well with Azure, but you can use other third-party analytics as well. For example, Azure supports New Relic, very popular analytics software. So now we see how we can add the proper type of database. And we're going to use either easy tables or we will use a SQL Server backend with Entity Framework. We saw how to create the database and the connection, and then of course create some tables to support our application and populate the database with some data. In this class, we covered how to create the server side of our Xamarin and Azure application. In the next classes, you're going to learn how to create the Xamarin side, the mobile client side of the application. And then in upcoming classes, we'll also focus on things like authentication. Thank you for watching Azure 110, Building an Azure Mobile App Service with Xamarin University. If you have any questions, please post a question in the Xamarin University forums or schedule an office hour with an instructor. Thank you and happy coding.